The night air moves differently over open water, carrying with it a faint coldness that seems to come not from the wind itself, but from somewhere much deeper, somewhere beneath the surface, where temperature and pressure follow different rules, where the ordinary calculations of atmosphere give way to something older and more patient. There is a particular quality to darkness when it meets the ocean, not the sudden blackness of a closed door, but a gradual dissolution, a slow negotiation between what can be seen and what must simply be felt, between the world that reflects light and the world that absorbs it completely, holding it in depths that have never known brightness, that have existed in a stillness so profound it makes the night sky seem restless by comparison. If you found yourself here, at this hour, drawn toward questions about what lies beneath the illuminated surface of things, then perhaps you've already sensed what this is about. Not a journey of revelation, but of gentle disappearance, of watching something familiar become something entirely other, degree by degree, meter by meter, until the very idea of seeing transforms into something quieter, something that doesn't require light at all. If this kind of contemplation helps you find stillness before sleep, you can subscribe to Quiet Science and continue these slow explorations with us, descending alongside ideas that don't demand urgency, that allow darkness to be what it actually is. Not an absence, but a presence of its own. The ocean holds approximately 335 billion cubic kilometers of water, a number so vast it loses meaning in the mind, and yet within this immensity, there exists a vertical architecture, a layering of zones where physics and biology negotiate the terms of existence with extraordinary precision. Light enters this realm the way all energies enter systems, with abundance at first, with seemingly inexhaustible momentum, and then it begins the one journey from which nothing returns unchanged. Downward, through increasing density, through water molecules that accept photons like hosts receiving guests who will never leave, absorbing wavelengths in an order so predictable it could be called inevitable. Red light, with its longer wavelengths and lower energy, surrenders first, vanishing within the first meters, and then orange, and then yellow, each color representing not just a visual quality, but a specific frequency of electromagnetic radiation, each one meeting its particular depth of impossibility, until only blue remains, and then, deeper still, even blue becomes memory. Water is not empty space through which light passes unchanged, the way it seems to move through air during daylight hours, arriving at our eyes with its qualities intact. Water is dense with molecules, with hydrogen and oxygen bound in configurations that create a medium fundamentally different from the atmosphere above. And light, when it crosses that boundary between air and ocean, enters a realm where every property it possesses will be tested, where every photon becomes subject to forces that will determine how far it travels and what it becomes along the way. The transformation begins instantly at the very surface, in that trembling membrane between two worlds where wavelengths meet resistance for the first time, where refraction bends their paths, and scattering sends them spiraling in directions they never intended to go. If you were to descend with a light meter, with instruments sensitive enough to measure the subtle changes that occur in the first meter, the first 10 meters, you would witness something remarkable. Not a sudden plunge into darkness, but a statistical negotiation, a probabilistic journey where each photon has its own story, its own encounter with matter, its own moment of either continuing deeper or being absorbed entirely, converted from electromagnetic radiation into the faintest warmth, into molecular vibrations so slight it barely registers as heat at all. The human eye, adapted through millions of years to function in air, evolved to interpret light that travels roughly 300,000 kilometers per second through the relative emptiness of atmosphere, hitting objects and bouncing back with information about shape, distance, color, texture. But in water, light slows, moving at approximately 225,000 kilometers per second. And this reduction in speed is not merely a technical detail, but a fundamental shift in how energy moves through space, how information about the world becomes available or withheld. 10 meters down, you are still in what scientists call the epipelagic zone, the sunlight zone, where photosynthesis remains possible, where the ocean is productive and bright relative to what lies below. And yet, even here, even in these shallow depths where swimmers and snorkelers move with ease, nearly half of the red light that entered at the surface has already vanished, absorbed by water molecules that preferentially take longer wavelengths first, converting them into imperceptible increases in ocean temperature, into thermal energy that will eventually disperse according to currents and gradients that operate on scales far larger than any individual ray of light could comprehend. The ocean, in this sense, is a patient collector, accepting light the way a forest accepts rain, knowing that most of what arrives will be transformed rather than transmitted, that the gift of energy from the sun will be spent here in these upper layers, fueling the microscopic engines of phytoplankton and the slow chemistry of photosynthesis, rather than penetrating to the depths where darkness is already and has always been the prevailing condition. 20 meters down, and orange begins to fade, its wavelengths stretched just long enough, its energy distributed across a spectrum that water finds increasingly easy to absorb, and what remains of the visible world starts to shift toward cooler tones, toward the blues and greens that will dominate the middle depths, the region where divers first begin to notice that colors they took for granted at the surface, the warm reds of coral, the vivid oranges of tropical fish, no longer appear as they did in sunlight, but instead fade into muted browns and greys, not because the pigments themselves have changed, but because the wavelengths needed to reveal them are no longer present, have already been spent, used up by water in its role as mediator between the sun and the deep. This is not theft, not loss in any tragic sense, but simply the physics of absorption, the way materials interact with electromagnetic radiation according to their molecular structure, according to laws that don't consider beauty or preference, but only the probabilities of quantum interactions, the likelihood that a photon of a given energy will encounter a water molecule and transfer its energy, rather than continue its journey downward into increasing pressure and increasing cold. 30 meters, and yellow light is now mostly memory, and the diver who descended this far begins to exist in a world that feels subtly different, not just darker, but qualitatively other, as if the ocean is gradually revealing its true nature, which is not the bright surface we know from beaches and boats, but something more interior, more private, a place where light is a visitor rather than a permanent resident, where darkness waits patiently below, not as threat, but as the natural state of most water, most volume, most of what the ocean actually is when you account for depth rather than just surface area. The temperature has likely dropped several degrees by now, depending on season and latitude, and this cooling is part of the same story as the dimming light. Both are aspects of depth. Both are consequences of distance from the sun's direct influence. Both contribute to the sense that descent is not just a change in location, but a transition between fundamentally different environments, each with its own rules about what is possible and what must be surrendered. Sound travels differently here too, moving faster through water than through air, carrying farther, wrapping around obstacles in ways that create acoustic landscapes the human ear was never designed to interpret fully. And perhaps this is part of what makes the ocean feel so alien, even to those who spend their lives studying it. Not just that it is dark or cold or vast, but that every sense we possess must be recalibrated. Every expectation about how the world works must be gently revised, one depth at a time, one wavelength at a time, until we find ourselves in a place that operates according to principles we understand intellectually, but can never quite feel as native, can never quite accept as home the way we accept the bright, warm, air-breathing world of the surface. And yet the ocean does not ask for our comfort, does not adjust itself to human preference or human scale, but simply continues its ancient work of layering, of sorting energy and matter according to density and depth, creating zones that stack vertically like floors in an impossibly tall building, each one darker than the one above, each one colder, quieter, more patient, as if the ocean is teaching something about inevitability, about the way all things eventually settle, eventually find their proper level in the architecture of pressure and light, eventually come to rest in the specific darkness that matches their nature. Red is the first color to disappear, not because it is weaker or less persistent than other wavelengths, but because its nature, its very structure as electromagnetic radiation, makes it particularly vulnerable to water's molecular embrace. Light travels as waves, and the distance between the peaks of those waves determines what we perceive as color. Red light has the longest wavelengths in the visible spectrum, stretching approximately 700 nanometers from crest to crest, while blue light compresses that distance to around 450 nanometers. And this difference, measured in billionths of a meter, creates everything we understand as color. Everything that allows us to distinguish a sunset from the sky at noon, a rose from the ocean itself. But wavelength is also energy, inversely related. Longer waves carry less energy per photon, and when red light encounters water molecules, when those photons collide with the hydrogen and oxygen atoms that make up H2O in its endless repeating configurations, they lack the energy to push through with the same probability that shorter wavelengths possess, and so they are absorbed, taken in, their electromagnetic energy converted to molecular motion, to heat so slight and so quickly dispersed, that it might as well not exist at all, except as one more contribution to the ocean's total energy budget, one more photon that will never reach the depths, that surrendered within the first 10 meters and became something other than light. At 15 meters, most of the red is already gone. And what this means for anything living at this depth is that red pigments no longer function as signals, no longer communicate what they were designed to communicate in the bright air above. A poisonous frog, a flowering plant, a warning or an invitation rendered in crimson or scarlet. Instead, red becomes grey, becomes shadow, becomes indistinguishable from the background. And this is why many deep-sea creatures have evolved to be red themselves, wearing a color that amounts to invisibility in their realm. A camouflage so perfect it requires no pattern, no texture. Only the simple fact that the wavelengths needed to reveal them are absent, used up, spent in the layers above. There is something quietly profound about this. The way evolution discovered that to hide in darkness you need not be black, but only colored in a spectrum that darkness has already consumed, already transformed into something else, into warmth or chemical energy, or the subtle vibrations of molecules that will never add up to anything a human eye would recognize as color. The ocean is full of such paradoxes, such elegant solutions to problems that only exist because of how light and water interact, because of physics that cares nothing for intention, but creates conditions that life must navigate with whatever tools natural selection provides. By 30 meters, orange light joins red in its absence, and the underwater world begins to shift perceptibly toward blues and greens, toward the shorter wavelengths that penetrate more readily because they carry more energy per photon, because their compact wave structure allows them to dodge and weave through water molecules with greater probability of continuation rather than absorption. A diver at this depth, even one carrying no artificial light, can still see clearly in daylight hours. The sun still reaches here, still illuminates. But the quality of that illumination has changed in ways that are difficult to describe to someone who has never experienced it, like trying to explain moonlight to someone who has only known noon. The colors that remain are colder, more distant, and there is a flatness to the visual field, a reduction in contrast that comes from the way water scatters light in all directions, creating a soft, diffuse glow, rather than the sharp shadows and bright highlights that define vision in air. Photographers who work at these depths must bring lights not just to see, but to restore the colors that water has taken, to briefly recreate a full spectrum in small pockets of artificial brightness, revealing reds and oranges that are technically still there, still present in the pigments of fish and coral, but functionally invisible without wavelengths to illuminate them, without the specific frequencies that would bounce off those surfaces and carry information about their color back to a camera or an eye. 50 meters down, and yellow begins its slow withdrawal, its photons encountering enough water molecules, enough opportunities for absorption, that the probability of any individual yellow photon surviving this far becomes statistically unlikely. and the ocean narrows its palette further, approaching a realm that will soon be dominated almost entirely by blue, by the shortest visible wavelengths that water permits to pass, that find the molecular structure of H2O least obstructive, least eager, to convert them into other forms of energy. This is the depth where the epipelagic zone, the sunlight zone, begins to show its limits, where productivity starts to decline because even the hardy phytoplankton that have adapted to lower light levels find themselves approaching the compensation depth, the point at which the energy they gain from photosynthesis equals the energy they expend simply staying alive, maintaining their cellular machinery, repairing the inevitable damage that comes from existing in a realm where every resource is measured, where every photon counts, where the abundance of the surface is already becoming memory, already transforming into the scarcity that defines most of the ocean's volume, most of its depth, most of its actual character beneath the thin, bright skin we think of as the sea. The human eye can detect light across a range of wavelengths from about 380 to 700 nanometers, a spectrum that corresponds to what we call violet through red, and this range represents only a tiny fraction of the electromagnetic spectrum, only the portion that happened to be most abundant in the sunlight that reaches Earth's surface, that happened to be most useful for organisms trying to navigate and hunt and find mates in the bright, air-filled world where our ancestors evolved. But the ocean was never designed for human vision, was never organized around the specific wavelengths we can perceive, and as depth increases, as colors vanish one by one, in an order determined entirely by physics, by the interaction between light waves and water molecules, it becomes clear that visibility, what we think of as seeing, is a luxury, a condition that exists only in certain places, under certain circumstances, and that most of the ocean exists in a state where different rules apply, where different senses become primary, where the absence of color is not a deficiency, but simply the natural state of water when you account for how much of it lies between the surface and the seafloor, how many opportunities light has to be absorbed, transformed, spent, before it could ever hope to reach the bottom and reflect back, completing the round trip that vision requires, that our eyes assume as the basic structure of how the world becomes known. Blue persists where other colors cannot, not through any inherent superiority, but because its wavelength sits at the precise intersection of energy and size that water finds most difficult to absorb. Photons compressed to approximately 450 nanometers, cycling at frequencies high enough to carry sufficient energy to negotiate the molecular obstacles that longer wavelengths cannot overcome, yet not so short that they cross into ultraviolet territory, where water becomes opaque again for different reasons. At 70 meters, 80 meters, as depth continues to accumulate above and pressure begins to assert itself in ways that cannot be ignored, the ocean settles into a realm of almost pure blue, a monochromatic world where everything takes on the color of the light that remains, where fish and rock and the drifting particles of organic matter that scientists call marine snow all appear in shades of azure and navy and cobalt, not because they lack pigmentation, but because only blue wavelengths remain available to reveal them, to bounce off their surfaces and carry information back to any eye adapted to see in these diminished conditions. This blue is not the bright, cheerful blue of a summer sky or a painted wall, but something deeper, something that seems to come from within the water itself, rather than from any external source, as if the ocean is generating its own light through some internal process, rather than merely filtering sunlight from above. Physicists call this the Rayleigh scattering of light, the same phenomenon that makes the sky blue, where shorter wavelengths scatter more efficiently than longer ones when they encounter molecules or particles smaller than their wavelength. And in water, this scattering creates a diffuse, directionless glow that makes it difficult to determine where light is coming from, whether it arrives from above or seems to emanate from all directions at once, from the water itself, from the space between, molecules, from the very medium through which you move. Divers describe this quality as otherworldly, as dreamlike, and perhaps what they sense is the strangeness of existing in an environment where the rules of illumination have been fundamentally altered. where shadows no longer fall in predictable directions, where the bright point of the sun above has been diffused into a general luminescence that decreases with depth, but never quite points the way back to the surface, the way shade and sunlight do on land. At 100 meters, we approach what oceanographers consider the edge of the epipelagic zone, the lower boundary of the sunlight layer, though the naming itself reveals the human tendency to think of light as binary, as either present or absent, when in reality, what happens here is far more gradual, far more subtle, a continued dimming, a further narrowing of the spectrum, a progressive reduction in the number of photons reaching this depth until photosynthesis becomes impossible for even the most light-adapted organisms, until the energy available from the sun becomes insufficient to support the complex chemistry of splitting water molecules and fixing carbon dioxide into sugars, into the organic compounds that form the base of the ocean's food web in the layers above. Yet even here, even at the threshold of what humans call the twilight zone, the mesopelagic region where darkness begins to dominate, there is still light, faint, blue, barely measurable with instruments, invisible to human eyes without time to adapt, but present nonetheless. A reminder that the ocean's layers do not snap into categories the way our diagrams suggest, that nature prefers gradients to boundaries, preferences, transitions that unfold across tens or hundreds of meters, rather than switching cleanly from one state to another. The intensity of light decreases exponentially with depth, following a mathematical relationship that can be expressed as I, or I0e, right, kz, where I represents the light at depth, z, I0 is the surface light intensity, k is the attenuation coefficient specific to the water's clarity and the light's wavelength, and e is the mathematical constant approximately equal to 2.71828, the base of natural logarithms. This equation might seem abstract, divorced from the physical experience of descent, but it describes something profound, that each meter downward removes a consistent percentage of the remaining light rather than a fixed amount, that the dimming accelerates as you go deeper, not because water becomes more absorptive, but because there is progressively less light left to absorb, because each layer processes what arrives from above and passes on only a fraction to the layer below, creating a cascade of reduction that feels organic, inevitable, like watching someone fall asleep, watching consciousness dim degree by degree until the boundary between waking and dreaming becomes impossible to identify with precision, exists only as a gradient we pass through without realizing the exact moment of transition. Blue light at 100 meters carries roughly 1% of the surface intensity, meaning that 99% of the photons that entered at the surface have been absorbed or scattered back toward the sky, converted to other forms of energy, or reflected away before they could reach this depth, and yet that remaining 1% is still enough to see by, still enough to create a visible world for creatures adapted to these conditions, for fish whose eyes have evolved to gather and concentrate the sparse photons available, whose retinas contain high concentrations of rod cells rather than cones, trading color vision for sensitivity, accepting a monochromatic world in exchange for the ability to detect movement, shapes, the silhouettes of prey or predator outlined against the faint glow from above. There is an efficiency to this arrangement, a pragmatism that evolution discovers when resources become scarce. Keep only what is necessary, discard everything else, accept the limitations that depth imposes, and find ways to thrive within them rather than resisting, rather than trying to maintain capabilities that served well in other environments, but become costly luxuries where light itself becomes a rationed resource, where every adaptation must justify its metabolic expense. The blue realm, then, is not merely a place of reduced light, but a zone of transformation, where the ocean begins to reveal its true nature as a vertical landscape of niches and adaptations, where each depth selects for different strategies, different solutions to the fundamental problem of extracting energy from an environment that becomes progressively less generous, less forgiving, as distance from the sun increases and the mathematics of exponential decay assert themselves with patient inevitability, creating conditions that seem impossible from the surface but become, at their own depth, simply the way things are. The normal state of existence for organisms that have never known brightness, that evolved in blue and will remain in blue until the slow processes of geology or climate shift the boundaries of their world in ways that operate on timescales far longer than any individual life, any species, any epoch of abundance or scarcity that humans could witness or measure. Between 100 and 200 meters lies a transitional realm that marine biologists have named the mesopelagic zone, though the term itself, derived from Greek roots meaning middle and sea, fails to capture the essential strangeness of this layer, the way it exists between conditions rather than as a distinct environment with clear boundaries. The way organisms here must navigate not just physical space, but the ambiguity of living where neither full light nor complete darkness prevails, where the very concept of day and night begins to lose the crisp definition it possesses at the surface. At 200 meters, sunlight has been reduced to less than 1% of surface intensity, and even that remaining fraction continues to dim as depth increases, fading toward a threshold that human eyes, even after extended dark adaptation, cannot cross, approaching a level of illumination so faint that it exists primarily as a statistical phenomenon, as photons arriving so infrequently that they must be counted individually rather than measured as continuous streams, as discrete events. Rather than as the steady flow we associate with light in the world above. This is the twilight zone, and the name suggests something romantic, something gentle, like the hour after sunset when the sky holds color, but the stars begin to appear, when the world softens and vision becomes uncertain, but not yet impossible. But oceanic twilight is not measured in minutes or hours. It is a permanent state, a condition that persists regardless of what the sun does above, whether it climbs to noon or sets beyond the horizon, because the water column itself has become the mediating factor, the determining variable, and 200 meters of seawater creates a dimness that overwhelms any daily cycle, that reduces the difference between day and night to something so subtle that only the most sensitive instruments can detect it. And even then, the distinction matters less than the simple fact of pervasive gloom, of existing in a realm where light is always scarce, always precious, always insufficient for the kind of vision that surface dwellers take for granted. The animals here, the lanternfish and hatchetfish, the squid and jellyfish and countless other species that make the mesopelagic zone the most densely populated habitat on Earth by biomass, have adapted to this condition not by developing better eyes, not by finding ways to gather more of the sparse photons that trickle down from above, but by accepting twilight as the baseline, as the normal state against which all other conditions are measured, and many of them engage in something called diel, vertical migration, rising toward the surface at night, when darkness above matches the darkness of their home depth, when they can feed in more productive waters without the risk of being silhouetted against bright surface light, visible to predators from below, and then descending again as dawn approaches, retreating to the safety of dimness, to depths where their dark bodies blend into the general gloom and offer no contrast, no outline, no target. But what does it mean for time itself when day and night lose their distinction? When the rhythm that organizes most surface life, the 24-hour cycle of light and dark that governs sleep and waking, feeding and rest, activity and stillness, becomes muted to the point of irrelevance? The mesopelagic zone suggests an answer through its very existence. That time can be measured in ways other than solar cycles, that patterns can emerge based on temperature gradients or current shifts, or the vertical migrations of prey species, that an organism can live its entire existence in twilight and still possess rhythms, still follow schedules written not in the sky but in the water itself, in the subtle variations of pressure and chemistry, and the presence or absence of other living things. There is a certain liberation in this, a freedom from the tyranny of daylight, from the expectation that brightness equals activity and darkness equals rest, and perhaps this is one reason why the mesopelagic zone harbors such diversity, such unexpected abundance, because it exists outside the binary that governs so much of terrestrial life, because it offers conditions that require new solutions, new adaptations, new ways of organizing existence around resources that are distributed differently, that follow rules the surface never taught. Temperature at 200 meters has dropped to perhaps 5 or 6 degrees Celsius in temperate waters, significantly colder than the sun-warmed surface, but still far from the near-freezing conditions of the deep ocean. And this thermal layering is itself a consequence of how energy moves through water. How heat, like light, penetrates only so far before it is absorbed and dispersed, before the sheer volume of water below acts as a vast reservoir of cold, a sink that draws warmth downward, through conduction and convection, but can never be fully heated by the distant sun, never reach equilibrium with the surface because the scale is too large, the depth too great, the water too effective at absorbing and redistributing energy across three-dimensional space. Cold water is denser than warm water, and so it settles naturally to the bottom, creating a stable stratification that persists across seasons and centuries, that defines the ocean's vertical structure as surely as gravity defines its presence in the basin of the seafloor. And organisms that live in this cold must maintain their metabolism, their cellular processes, their muscle function and nerve conduction in conditions that would slow or stop many surface species, that would require them to expend enormous energy just maintaining body temperature. But the creatures here are adapted, are cold-blooded in most cases, allowing their internal temperature to match their environment, accepting sluggishness as the price of efficiency, moving slowly but continuously through water that never warms, that never offers the metabolic boost that temperature provides to organisms in tropical shallows or sun-heated tide pools. The pressure at 200 meters is approximately 20 times atmospheric pressure at sea level, meaning that every square centimeter of an organism's body experiences 20 kilograms of force pressing inward from all directions, a condition that would crush air-filled spaces, that would compress lungs and ears, and any cavity containing gas. But the creatures here are mostly water themselves, mostly incompressible, their bodies at the same pressure as the surrounding ocean, achieving equilibrium not through resistance, but through acceptance, through being made of materials that do not fight pressure, but simply exist within it, unfazed, unaffected, as comfortable at 20 atmospheres as a human is at 1, because pressure, like twilight, like cold, is not an obstacle to be overcome, but a parameter to be inhabited, a condition that defines what is possible and what is not, what forms life can take, and what strategies will succeed in extracting energy from an environment that offers little margin for error, little forgiveness for inefficiency, little tolerance for organisms that cannot find ways to thrive in dimness and cold, and the weight of water stacked hundreds of meters deep above their heads, pressing down with patient, inexorable force that neither increases nor decreases but simply is, has always been, will always be for as long as the ocean exists, and depth remains a defining characteristic of its nature. In the deepening twilight, where sunlight becomes more concept than reality, where the few photons that manage to penetrate this far arrive exhausted and scatter in all directions until they become indistinguishable from darkness itself, life has discovered an alternative, a way to generate illumination from within, rather than waiting for it to arrive from above. And this capability, bioluminescence, the production of light through chemical reactions contained within living tissue, transforms the mesopelagic zone into something unexpected, something that contradicts our assumptions about what darkness means, what it contains, whether the absence of sunlight necessarily implies the absence of light altogether. The chemistry is elegant in its simplicity. A molecule called luciferin reacts with oxygen in the presence of an enzyme called luciferase, and the energy released by this reaction emerges not as heat, but as photons, as visible light produced with extraordinary efficiency, with almost no waste, with a cold brilliance that requires no flame, no electricity, no external power source, only the molecular machinery that evolution has refined over hundreds of millions of years, that exists now in organisms across dozens of phyla, from bacteria to fish to squid, each lineage having discovered bioluminescence independently, having arrived at this solution through separate evolutionary paths that converged on the same basic truth: that in darkness, the ability to make light confers advantages worth the metabolic cost of maintaining the biochemical apparatus required. A single lanternfish, barely 10 centimeters long, carries rows of photophores along its belly and sides, specialized organs that contain light-producing cells, often with reflective layers behind them and color filters in front, creating structures as sophisticated as any human-designed lamp, focusing and directing the emitted photons with precision that serves specific purposes, specific survival strategies that have been tested and refined across countless generations living in this twilight realm. Some use their lights for counter-illumination, a form of camouflage where the fish matches the faint downwelling light from above, eliminating its silhouette when viewed from below, becoming effectively invisible to predators that hunt by looking upward for dark shapes outlined against the slightly brighter water above. And the fish must constantly adjust the intensity of its ventral photophores as it moves through different depths, different light levels, maintaining the perfect match between its self-generated glow and the ambient illumination, performing a continuous calculation that means the difference between survival and becoming someone else's meal. Others use bioluminescence for communication, flashing patterns that are species-specific, sex-specific, sometimes individual-specific, creating a visual language in the near darkness that allows recognition, allows coordination, allows the complex social behaviors that persist even here, even in conditions where you might assume that isolation would be the default state, that individuals would drift through the gloom without encountering their own kind. But life, as always, finds ways to gather, to signal, to reach across the darkness with flashes of blue-green light that say, "I am here. I am this species. I am receptive or territorial or ready to mate," all communicated in pulses and patterns that only the intended recipient understands. The color of bioluminescence is not random, but constrained by both chemistry and environment. Most marine bioluminescence emits blue or blue-green light, wavelengths around 470 to 490 nanometers, and this preference exists because blue light travels farthest in seawater, because the same properties that allow blue sunlight to penetrate deeper than other colors also allow blue bioluminescence to be seen at greater distances, to carry signals farther through the scattering, absorbing medium of the ocean. And there is something aesthetically perfect about this, about the way the wavelength that survives longest from the sun above is also the wavelength that life chooses when it creates its own light, as if the ocean has taught all its inhabitants the same lesson about what works here, what succeeds, what colors are worth producing when you live in a realm where visibility itself is precious, where every photon matters and waste is a luxury no one can afford. Some deep-sea creatures have evolved to see red bioluminescence, a rare capability that allows them to illuminate prey with a color that most other organisms cannot detect, essentially creating invisible searchlights that reveal targets without alerting them, without triggering the escape responses that visible light would cause. And this adaptation, both the ability to produce red light and the eyes to see it, represents a kind of evolutionary arms race, a continuous competition between strategies of revelation and concealment, between making light and remaining hidden, between seeing and being seen. But perhaps the most profound aspect of bioluminescence is what it suggests about energy, about the ways that life can store and release it, about the fact that organisms have learned to capture energy from food, from the smaller organisms they consume, from the chain of consumption that ultimately traces back to sunlight captured by photosynthesis in the upper layers, and then convert that chemical energy not just into movement or heat or the maintenance of cellular processes, but into light itself, into photons that did not exist before, that represent new information injected into the environment, new signals that other organisms can detect and respond to, creating feedback loops of communication and deception, attraction and warning, all mediated by flashes and glows that exist for seconds or milliseconds before dissipating back into the darkness that is, in this realm, always waiting, always ready to reclaim the space that bioluminescence briefly illuminates. The mesopelagic zone at night, though Night here means something different, means only the absence of even the faint, downwelling sunlight that provides daytime's minimal illumination, becomes a field of moving lights, of organisms rising from deeper water to feed, of predators and prey engaged in eternal games of hide and seek, where light is both tool and liability, where the decision to emit photons must be weighed against the risk of attraction, where every flash says "here I am" to both potential mates and potential threats. And the strategies that succeed are those that navigate this trade-off with precision, with timing, with an understanding written into instinct about when light serves and when silence, visual silence, the choice to remain dark, offers better odds of survival. The darkness here is not empty then, but populated with intentions, with organisms making choices about when to reveal themselves and when to vanish. And the resulting lightscape, if we could see it, if our eyes were sensitive enough, or if we descended with cameras capable of detecting faint bioluminescence, would resemble a slow-motion fireworks display, a constellation of moving stars that wink in and out of existence, that trace paths through three-dimensional space according to purposes we can only infer, only speculate about based on the species involved and the behaviors observed. And even then, much remains mysterious. Much falls into the category of phenomena we have witnessed but not fully understood, of patterns that suggest meaning without revealing it completely, of a visual language spoken in a realm where humans are visitors at best, where our presence requires technology, requires lights and cameras and pressure-resistant vehicles, requires us to bring our own illumination. Because the darkness here, despite its scattered stars of bioluminescence, remains fundamentally dark, fundamentally other, fundamentally organized around principles that did not emerge from the bright surface world where our species learned to see. Light does not fade randomly as depth increases, does not diminish according to chance or whim, but follows instead a mathematical law so consistent, so predictable, that it can be expressed in a single equation, can be plotted on a graph that shows the same curve regardless of whether you measure it in the Pacific or the Atlantic, in tropical waters or polar seas, in spring or winter or any hour of any day, because the relationship between depth and light intensity is exponential, is governed by a function that describes not linear subtraction but proportional reduction, where each additional meter of water removes not a fixed amount of light, but a fixed percentage of whatever light remains, creating a cascade that accelerates as you descend, that appears to slow only because there is progressively less light left to absorb, less illumination available to be taken away. If you begin with 100% of surface light intensity and descend to 10 meters where perhaps 60% remains, then the next 10 meters will not reduce the light by another 40 percentage points to 20%, but will instead reduce the 60% by roughly the same proportion, leaving perhaps 36% at 20 meters, and then 22% at 30 meters, and then 13% at 40 meters, each step taking a similar fraction of what arrived from above, each layer processing and filtering and keeping its share of photons, until what continues downward becomes increasingly sparse, increasingly precious, increasingly inadequate for the biological processes that depend on light as an energy source or an information carrier. This exponential decay is not unique to light in water. It describes radioactive half-lives and the cooling of hot objects and the dissipation of sound in air and countless other natural processes where something diminishes in proportion to how much of it remains, where the rate of loss depends on the current quantity rather than on time alone or distance alone. And perhaps there is something comforting in this universality, in the way that diverse phenomena follow the same mathematical architecture, obey the same fundamental relationship between what is and what changes, between abundance and scarcity, between presence and gradual disappearance. The curve that describes light attenuation with depth is smooth and continuous, contains no sudden drops or unexpected plateaus, no points where the pattern breaks or reverses. And if you were to descend slowly enough, measuring continuously, you would trace this curve with your instruments, would confirm that nature in this instance is remarkably well behaved, remarkably consistent, that the ocean does not play tricks with light, but processes it, according to laws that have held steady since. Water first accumulated in the basins of the early Earth, since the first photons from the first sun encountered the first molecules of the first ocean and began this ancient exchange of energy, this transaction that has been repeating, with minor variations in clarity and wavelength composition, for billions of years. At 300 meters, we have crossed well into the mesopelagic proper, and the light that reaches here represents less than 0.1% of surface intensity, not quite zero, not yet complete darkness, but so dim that human eyes would register nothing, would report blackness despite the fact that sensitive instruments still detect photons arriving from above, still measure a statistical trickle of electromagnetic radiation that has survived the journey through hundreds of meters, of water, through countless opportunities to be absorbed or scattered, through a gauntlet of molecules and particles that reduce the once bright sunlight to something barely distinguishable from the background noise of the universe, from the faint glow of distant stars, or the thermal radiation that all matter emits simply by virtue of possessing temperature above absolute zero. This is the depth where the distinction between twilight and darkness becomes philosophical rather than practical, where the question of whether light exists depends on how sensitive your measurements are, how many photons per second per square meter you are willing to count as illumination rather than as statistical artifacts, as random fluctuations that might represent light or might represent nothing, might be signal or might be noise in a realm where the two become increasingly difficult to distinguish. The mathematics of exponential decay contains within it a concept called the half-depth, the vertical distance required to reduce light intensity by 50%, and in clear ocean water, this value is approximately 20 to 30 meters for blue light, meaning that every 20 to 30 meters of descent cuts the remaining light in half, and after 3 such intervals, you are left with 1/8 of your starting intensity, after 4 intervals, 1/16, after 10 intervals, approximately 1,000th, and the progression continues. Relentless, but never quite reaching zero, because half of something, no matter how small, still leaves something, still produces a number greater than zero, even if that number has so many decimal places that it loses practical meaning, becomes a quantity that exists mathematically, but not experientially, not in any way that matters to organisms trying to navigate or feed or find mates in conditions where darkness is, for all intents and purposes, absolute. The ocean demonstrates through this pattern something about infinity, about the way that processes can continue forever without ever quite completing, can approach limits without reaching them, can get arbitrarily close to zero while never actually arriving. And perhaps this is why the transition from light to dark feels so gradual, so gentle, so lacking in clear boundaries, because it is an approach rather than a crossing, a journey toward a limit that recedes as you move toward it, always. Present as destination, but never quite achieved, because the mathematics ensure that some fraction, however tiny, will always remain. Yet for practical purposes, for the organisms that live here, and the humans who visit with their instruments and their curiosity, there comes a depth where the distinction between almost zero and actual zero no longer matters, where the few photons that might still be arriving from the surface contribute nothing useful, nothing detectable to the creatures adapted to this realm, and we might place that boundary somewhere between 400 and 500 meters, depending on water clarity, and the angle of the sun, and the season and latitude. But somewhere in this range, the last meaningful traces of sunlight give way entirely to darkness, to the permanent night of the bath, hypelagic zone that lies below, to depths where bioluminescence provides the only light that matters, where any photon not generated by a living organism represents an anomaly, an intrusion, perhaps the lamp of a research submersible, or the brief flash of a nuclear decay in a naturally radioactive isotope, dissolved in seawater, but nothing that could be called illumination, nothing that could organize vision or photosynthesis, or any of the light-dependent processes that define life in the layers above, in the realm where the sun's influence, however attenuated, still reaches, still touches, still connects the deep water to the bright surface through a chain of photons that gets longer and more tenuous with each meter of depth, but never entirely breaks until this point, until this threshold where exponential decay has finally reduced abundance to absence, has completed its mathematical work of transforming the bright gift of sunlight into the stillness of permanent dark. Time, as humans experience it, is largely a construct of light, not the mechanical ticking of clocks or the rotation of the planet, which continue regardless of our awareness, but the subjective sense of duration, the feeling of hours passing or compressing, the rhythm that organizes consciousness into periods of activity and rest, alertness and sleep, hunger and satiation, all of which are entrained to the solar cycle through mechanisms so deeply embedded in our biology that we carry them even into environments where the sun cannot reach, where no natural cues exist to mark the difference between morning and midnight. The suprachiasmatic nucleus, a small cluster of neurons in the mammalian brain, acts as a master clock, receiving input from specialized photoreceptor cells in the eye that detect light levels and use that information to synchronize circadian rhythms, approximately 24-hour cycles that govern everything from hormone release to body temperature to cognitive performance, to the external world, to the rotation of the Earth that creates the alternation of day and night that has structured life for billions of years. But remove the light, remove the sun's rising and setting, place an organism in continuous darkness or continuous brightness, and something interesting happens. The internal clock continues running, continues cycling through its programmed rhythms, but it begins to drift, begins to deviate from exactly 24 hours, because the internal mechanism, left to itself, is not perfectly calibrated, runs slightly fast or slightly slow, and without external cues to reset it daily, those small deviations accumulate until the organism's internal sense of time becomes desynchronized from the actual passage of time in the external world, until its subjective day might be 25 hours long or 23, until it begins to experience time in a way that no longer corresponds to the cycles that govern life at the surface. In the deep ocean, where light does not penetrate, where the distinction between day and night has been erased by hundreds or thousands of meters of water, organisms face a choice: maintain circadian rhythms that serve no obvious purpose, that respond to a solar cycle they cannot detect, or abandon those rhythms entirely. Allow their physiology to drift free of the 24-hour structure that constrains so much surface life, that divides existence into discrete periods and demands different behaviors, different metabolic states, different levels of alertness depending on the time of day. Some deep-sea species retain circadian rhythms, perhaps because their evolutionary ancestors lived in shallower water, perhaps because they still engage in vertical migrations that bring them close enough to the surface to detect faint changes in light levels, or perhaps simply because the genetic machinery that generates these rhythms is deeply conserved, difficult to eliminate entirely, even when it no longer provides clear advantages. But many others have lost their circadian clocks, or have allowed them to become so attenuated, so weak and irregular, that they barely function, leaving these organisms in a state that might be called temporal freedom, able to feed whenever prey appears, to rest whenever energy reserves deplete, to move or remain still based on immediate circumstances rather than on any schedule imposed by the position of the sun relative to the horizon, by the Earth's rotation, by the cosmic rhythm that organizes most terrestrial life into predictable patterns, but means nothing here, in the permanent dark, in the realm where time might be measured in other ways or not measured at all, where duration exists but cycles do not, where 1 hour resembles any other, not because they are identical, but because no external marker distinguishes them, because the darkness that prevails at midnight prevails equally at noon, because the ocean at depth creates its own temporal regime that operates independently of the bright spinning world above. The metabolic rate of deep-sea organisms is typically much lower than their shallow water relatives, a consequence of both cold temperature and scarce food resources, And this physiological slowing creates a different relationship with time, a different pace of existence where movements are economical, where hunting and foraging happen in slow motion by surface standards, where even processes like growth and reproduction unfold across years or decades rather than months or seasons, where life itself seems to have found a lower gear, a different operating speed that matches the energy available, that accepts scarcity as the baseline condition and adapts accordingly. A deep-sea fish might go days or weeks between meals, might encounter prey so infrequently that it must be prepared to consume nearly anything it finds, must have a digestive system capable of processing food items far larger than what would seem possible given the fish's own size, must be willing to wait in the darkness with minimal movement, minimal energy expenditure, allowing hours to accumulate without event, without activity, in a state that resembles neither sleep nor waking, but something in between, some low-power mode where consciousness, if it exists at all, flickers like a pilot light rather than burning bright, where awareness contracts to the minimum necessary for detecting the vibrations or chemical signals or bioluminescent flashes that might indicate food or danger, and otherwise remains quiescent, patient, adapted to a realm where haste serves no purpose, where speed offers no advantage, where the strategic choice is always to wait, to conserve, to exist as efficiently as possible until the rare moment arrives when action becomes necessary. This slowing of time, this shift toward a different temporal experience, might be one of the most profound adaptations to the deep ocean, more fundamental even than the physical modifications. The pressure tolerance, the cold adaptation, the enhanced light sensitivity, because it represents a reorganization of existence itself, a different way of being alive that does not divide experience into days and nights, seasons and years, but instead treats time as a continuous flow without natural divisions, without the punctuation that light provides, without the resetting that occurs when dawn arrives and new possibilities emerge, when the world brightens and activity increases and the metabolic engines that idled through the night rev up again in response to warmth and illumination. In permanent darkness, there is no such resetting, no moment when everything begins again, and perhaps this is why the deep ocean feels so alien to human consciousness, why it resists our attempts to understand it on our own terms. Not because the organisms are strange or the pressures extreme or the cold punishing, but because the temporal structure, the rhythm of existence, operates according to principles we cannot fully inhabit, cannot fully grasp, because our own sense of time is so thoroughly bound to light, to the sun's presence or absence, to the cycle that divides our lives into repeating units and gives us the illusion that time itself is structured, is segmented, is something that can be measured in discrete packets rather than experienced as an undifferentiated flow that continues without pause, without emphasis, without the peaks and valleys that light creates, that makes some hours feel important and others forgettable, that allow us to say today and yesterday, and mean something specific rather than arbitrary divisions of a continuum that has no natural breaks. At 1,000 meters, we cross an invisible boundary into the bathypelagic zone, the midnight zone as it is sometimes called, and here the last pretense of sunlight vanishes. The final statistical photons that might have reached this far are absorbed or scattered, or simply exhausted by their journey through a kilometer of water, through a vertical distance that equals 3 Empire State Buildings stacked atop one another, through a medium that has filtered and processed and taken its share, from every ray of light that entered at the surface, until nothing remains except darkness so complete that it seems less like absence and more like presence, like a substance in itself, like something that fills the space between organisms and creates the fundamental texture of this realm in the same way that air or water creates the texture of environments closer to the sun. The pressure here is approximately 100 atmospheres, meaning that every square centimeter of surface area experiences 100 kilograms of force, a compression that would collapse any air-filled chamber, that would reduce human lungs to uselessness, that would make the concept of breathing in the terrestrial sense impossible. But the organisms that inhabit this depth are made mostly of water and tissue that does not compress, that exists at the same pressure internally as externally, achieving equilibrium not through resistance, but through being composed of materials that simply do not care about pressure, that find 100 atmospheres as comfortable as one, that never knew any other condition, and therefore have no framework for understanding pressure as obstacle or challenge, only as the normal state of existence at this particular location in the vertical geography of the ocean. Darkness here is not the darkness of a moonless night on land, where even in the absence of artificial light some faint illumination usually remains, starlight, or the glow of distant cities, or the bioluminescence of fireflies in summer, but rather a darkness so profound that it defines the baseline against which all other darknesses are measured, a black that is not just the absence of visible light, but the absence of any electromagnetic radiation in the frequencies that human eyes can detect, that evolution designed us to perceive, because this environment, this zone, existed long before eyes evolved, existed when the Earth's oceans were young and life was simple, and vision had not yet been invented as a sensory strategy, when the first complex organisms were developing in shallow waters where light could penetrate, where the advantage of detecting photons and using that information to navigate or hunt had not yet been discovered by natural selection. And so, the bathypelagic zone represents in some sense a preservation of that ancient condition, that pre-visual world where other senses dominated: chemical detection, vibration sensing, temperature gradients, the electromagnetic fields that some organisms can perceive, where the question of what something looks like never arose because looking was not possible, because the medium and the distance from the sun conspired to create conditions where light simply did not exist as a resource, as information, as anything that mattered to survival or reproduction, or the daily business of extracting energy from the environment and converting it into the continuation of life. Yet the ocean here is not lifeless, not empty, not a void despite the darkness and the cold, and the pressure and the distance from the sunlit surface, where photosynthesis creates the organic matter that fuels most marine food webs. Because what the surface produces eventually sinks, falls through the water column as marine snow, a continuous gentle precipitation of dead plankton and fecal pellets, and the molted exoskeletons of crustaceans, and the mucus nets that filter feeders discard, all of it, drifting downward through hundreds or thousands of meters, decomposing as it falls, being consumed by organisms in the layers it passes through, so that what arrives at bathypelagic depths is only a fraction of what left the surface, perhaps 1 to 5% of the organic carbon that begins the journey. But that fraction is enough, is sufficient to support a sparse but persistent community of life that has adapted to making do with scraps, with the leftovers from the productive zones above, with an energy subsidy so diluted by the distance it must travel and the consumption that occurs along the way, that it barely qualifies as a resource, yet still represents the primary input of food, the foundation of the deep-sea food web that operates in complete darkness according to rules that have nothing to do with photosynthesis, nothing to do with plants or algae or the direct conversion of sunlight into chemical energy, but instead depend entirely on this vertical transfer, this rain of organic particles that never stops, that has been falling since the first organisms lived and died in the surface waters billions of years ago, that will continue falling as long as the ocean exists and life persists in its upper layers. The organisms that feed on marine snow must be patient, must be willing to sit or drift or move slowly through the water column, waiting for particles to arrive, filtering them from the current, or plucking them from the water with specialized appendages, or simply opening their mouths and hoping that something edible will drift in. And this lifestyle, sedentary or nearly so, metabolically suppressed, adapted to long periods of inactivity punctuated by brief moments of feeding, creates a different kind of ecology, a different pace of energy flow where the turnover is slow, where biomass accumulates gradually and persists for long periods, where individual organisms might live for decades or even centuries, growing slowly but continuously as long as food occasionally arrives, as long as the connection to the surface remains intact, as long as the marine snow continues its eternal descent through the darkness. That is, at this depth, not an anomaly or a challenge, but simply the way things are, the normal background condition against which all behaviors and adaptations have been selected, the medium in which life here evolved and continues to exist without any expectation that things could be otherwise, without any evolutionary memory of brightness or color or the daily cycle of light and dark that shapes existence in realms closer to the sun. The midnight zone extends from 1,000 to 4,000 meters, encompasses a vertical range larger than the height of most mountains, contains more water by volume than all the shallower zones combined, and throughout this vast space, the darkness remains constant, unvarying, unaffected by season or latitude or time of day, creating a uniformity of condition that is almost unprecedented in Earth's environments, a stability that persists across millennia, that changes only on geological timescales when ocean circulation patterns shift, or climate systems reorganize, or the continents drift and alter the shapes of ocean basins, but otherwise maintains its darkness and its cold and its pressure with a consistency that allows organisms to specialize, to adapt to these specific conditions without needing the flexibility to handle variation, without needing backup systems or alternative strategies for different circumstances, because the circumstances here are always the same, have been the same for millions of years, will be the same for millions more, offering a kind of temporal stability that is rare on Earth, that exists nowhere on land where seasons and weather create constant variation, constant unpredictability, constant demands for organisms to adjust, to prepare, to cope with changes that arrive daily or weekly or annually. But here, in the midnight zone, the only changes that matter operate on scales so large, so slow, that individual organisms never experience. Them never need to account for them in their moment-to-moment existence, in their hunting or feeding or reproduction, in the slow, patient work of staying alive in darkness that is not threatening but simply present, simply the medium through which life moves, unchanging and absolute. Pressure and darkness arrive together as depth increases, not as separate phenomena that happen to coincide, but as related consequences of the same fundamental fact that water has mass, that gravity pulls that mass downward, that every molecule in the water column contributes its weight to everything below, and that light, attempting to travel through this accumulated mass, finds itself absorbed and scattered by the sheer number of molecules it must pass through, by the density that increases, subtly with depth as water compresses under its own weight, becoming marginally more compact at 3,000 meters than at the surface, enough to affect the speed at which sound travels, enough to influence the behavior of dissolved gases, enough to remind us that water, despite appearing incompressible in everyday circumstances, does respond to pressure, does change its properties in ways that matter when you account for the full depth of the ocean, for the thousands of meters that separate the surface from the seafloor in the deep basins that occupy most of the planet's ocean area. At 2,000 meters, the pressure has reached approximately 200 atmospheres, and if you could somehow experience this pressure while maintaining human physiology, while keeping your body as it is adapted for surface conditions, the force would be catastrophic, would compress air spaces, would disrupt cellular processes, would make life impossible in any recognizable form. But the organisms here are not maintaining surface physiology. They are pressure adapted, composed of tissues and fluids that match the ambient pressure, that contain no air spaces to be crushed, that function normally under conditions that would destroy surface organisms not because they are stronger or more resilient, but because they are designed differently, are built according to a blueprint that assumes high pressure as the default state, that never needed to solve the problem of compression, because compression only occurs when internal and external pressures differ, when there is a gradient to be equalized, and at depth there is no gradient, no difference, only equilibrium. The darkness at 2,000 meters is the same darkness that existed at 1,000 meters, will be the same at 3,000 and 4,000, and every depth below until the seafloor itself provides a surface to reflect whatever faint bioluminescence might be present. And this constancy of darkness is part of what creates the profound stillness of the deep ocean. The sense that nothing here changes, that time has slowed to a pace where years pass like days and centuries accumulate without drama, without the punctuation that weather and seasons provide at the surface, without the constant variation that characterizes environments exposed to the atmosphere, to wind and rain and temperature fluctuations, and the daily solar cycle that reorganizes surface life into patterns of activity and rest, feeding and hiding, migration and reproduction. The deep ocean knows none of this, experiences instead a stability so complete that it resembles stasis, resembles a system that has reached equilibrium and remains there, unchanging, while the bright, chaotic surface world spins through its cycles overhead, entirely disconnected from the conditions below, entirely irrelevant to organisms that live their entire existence without ever sensing the sun, without ever knowing that such a thing as weather exists, as seasons, as the rising and falling of temperature that accompanies the planet's tilted rotation around its star. Water at depth moves slowly, if it moves at all, because the turbulence that characterizes surface waters, the waves and currents driven by wind, the mixing caused by solar heating and cooling, the upwelling and downwelling that circulates nutrients and oxygen, does not penetrate here, does not reach depths where the surface influence has been damped out by the sheer mass of water above, by the density stratification that keeps surface water separate from deep water, that creates layers that can persist for centuries without mixing, that allow the deep ocean to maintain its cold and its darkness and its pressure without interference from the variable, energetic conditions above. The currents that do exist at bathypelagic depths are slow, are driven by differences in temperature and salinity that create gradual density gradients, that move water horizontally across ocean basins at speeds measured in centimeters per second, in meters per day, in distances that require years or decades to complete, that circulate the deep ocean's volume through a global system of currents that touches every basin, every trench, every remote corner of the seafloor, but does so with such patience, such lack of urgency, that the word current almost seems too dynamic, too suggestive of movement and change, when what actually exists is more like a slow drift, a gradual repositioning of water masses that maintains the ocean's thermal structure, that distributes dissolved oxygen and nutrients and the chemical signatures of different water sources across the planet, but does so on timescales that make human life seem brief, that make even human civilization seem ephemeral, that operate according to a clock that measures time not in hours or years, but in the centuries required for surface water to sink at the poles and travel through the abyss, and eventually rise again in distant regions, completing a circulation pattern that has no beginning or end, no moments of transition, only continuous slow motion that persists as long as the ocean exists, and density differences provide the driving force. This stillness, physical, temporal, sensory, creates an environment that might be the closest thing Earth offers to the conditions of deep space, not in terms of temperature or pressure or the presence of matter, but in terms of constancy, in terms of the absence of variation, in terms of existing in a state where change happens so slowly that it cannot be perceived, where stability is not something achieved through active maintenance, but simply the natural condition, the default state from which there is no reason to deviate. An organism living at 2,000 meters experiences essentially the same conditions today that its ancestors experienced 1,000 years ago, will experience essentially the same conditions that its descendants will encounter 1,000 years hence, because nothing at this depth responds to the daily or annual variations that define life at the surface. Nothing here cares about whether it is day or night, summer or winter, whether the moon is full or new, whether the tides are high or low, because all of these phenomena are surface phenomena, are consequences of the interface between ocean and atmosphere, between water and air, and the gravitational influence of celestial bodies, and their effects diminish rapidly with depth until they become undetectable, until they contribute nothing to the conditions that matter, that influence survival, that shape the adaptations and behaviors of organisms that have evolved in this realm of unchanging darkness and cold and pressure. Perhaps this is why the deep ocean feels, to the human imagination, like a place of profound peace, like the ultimate refuge from the chaos and noise and constant stimulation of surface life, from the demands and urgencies that characterize existence in bright, variable environments where opportunities appear and disappear quickly, where timing matters, where the ability to respond rapidly to changing conditions determines success or failure, because the deep ocean offers none of that, imposes none of those demands, asks nothing except patience, except the willingness to exist slowly, to accept scarcity, to wait in darkness, without expectation of brightness, without hope of warmth, without the rhythms that make time feel structured, that divide existence into meaningful units, that provide the sense that one moment differs from another, that today is distinct from yesterday and tomorrow will bring something new, some change, some reason to believe that time progresses rather than simply accumulates. Life in complete darkness does not require vision, does not need eyes in the way that surface organisms do, and many species that inhabit the bathypelagic zone have reduced their visual apparatus accordingly, have allowed eyes to shrink or simplify or disappear entirely across evolutionary time because maintaining complex eyes, with their specialized photoreceptor cells, their intricate neural processing systems, their delicate lenses and precise focus mechanisms, requires energy, requires resources that are scarce at depth, requires an investment that makes sense only when light is available to be detected, when photons arrive with sufficient frequency to provide useful information about the environment, about the location of prey, or predators, or potential mates. But in complete darkness, eyes offer no advantage, detect nothing worth the metabolic cost of building and maintaining them, and so natural selection has gradually eliminated them from many deep-sea lineages, has produced species with eyes so reduced they appear as mere dimples or pigmented spots, or have vanished entirely, leaving smooth skin where surface ancestors once possessed elaborate visual organs, leaving no trace except in the genetic instructions that still contain, in vestigial form, the blueprint for building eyes, evidence that these organisms descended from ancestors that could see, that lived in brighter waters where vision mattered, before they colonized the depths and began the long process of adaptation to permanent night. Yet the absence of eyes does not mean these organisms are blind in any meaningful sense, does not mean they lack sensory awareness of their surroundings, because the ocean provides other forms of information, other ways to detect what matters, prey, predators, obstacles, mates, and deep-sea species have enhanced these alternative senses to compensate for what vision would have provided, have developed extraordinary sensitivity to chemical signals dissolved in water, to vibrations that propagate, through the medium as pressure waves, to the subtle electrical fields that all living organisms generate through their metabolic processes, through the movement of ions across cell membranes, through muscle contractions and nerve impulses that create tiny voltages detectable by specialized organs called electroreceptors, by structures that can sense the presence of another organism from meters away, based purely on its electrical signature, on the field disturbances it creates simply by being alive, by maintaining the electrochemical gradients that life requires. These senses, invisible to humans who rely so heavily on sight and sound, create a perceptual world entirely different from the visual one we inhabit, a world built from chemical gradients and pressure waves and electromagnetic fields, where objects have different properties, where distance is measured not in how far something can be seen, but in how strongly its signals propagate, how clearly its presence registers against the background noise of the ocean's constant molecular activity. The lateral line system, present in all fish but particularly well developed in deep-sea species, consists of mechanoreceptors arranged in canals along the body and head that detect minute changes in water pressure, minute flows and currents that indicate movement nearby, that allow a fish to sense the approach of prey or predator even in complete darkness, even with no bioluminescence to provide warning, because movement through water creates pressure disturbances, creates waves that propagate, outward from the moving body and can be detected by an organism sensitive enough, patient enough, still enough to notice the subtle changes in the pressure field that surrounds it. A blind fish, motionless in the darkness, can detect a swimming organism from several body lengths away, can determine its direction and speed, and approximate size based purely on the pattern of pressure waves it generates, can decide whether to strike or flee, or remain motionless, hidden by stillness, by the absence of movement that would reveal its own position to whatever predator might be hunting nearby, might be using its own lateral line to scan the darkness for vibrations, for any sign of life disturbing the water's natural quiescence. Chemoreception in the deep ocean operates at extraordinary sensitivity, detecting individual molecules of amino acids or other organic compounds that leak from organisms, that drift away from injuries or waste products, or the mucus that coats fish scales, creating chemical trails that persist in the slow-moving water, that spread gradually through diffusion and weak currents until they become too diluted to detect, but which, close to their source, provide clear directional information. Allow an organism to follow the gradient upstream, toward increasing concentration, toward the source that emitted them, whether that source is food or a potential mate, whether the trail leads to opportunity or danger. Some deep-sea species have elaborate barbels, whisker-like appendages covered in chemoreceptors, that they extend into the water as they move, sweeping through space like blind fingers searching for chemical signals, for the molecular traces that other organisms leave behind, and these barbels can detect concentrations so low they barely qualify as information, as signal distinguishable from the background chemical noise of seawater. But evolution has refined these systems across millions of years of living in darkness, has pushed sensitivity to limits that seem almost impossible, almost magical, until you remember that selection operates on small differences, that an organism even slightly better at detecting food will have more offspring, will pass on its genetic advantages, and over many generations, those small improvements accumulate, compound, transform adequate sensitivity into exquisite sensitivity, into capabilities that exceed what seems necessary, but represent the evolutionary optimum for organisms living in environments where every calorie counts, where the difference between detecting prey and missing it might mean the difference between surviving or starving. These organisms do not experience their sensory world as limited or impoverished compared to the visual world of surface animals. They have no basis for comparison, no evolutionary memory of sight, no sense that they are missing anything. And this is perhaps the most profound aspect of deep-sea adaptation, that darkness is not deprivation for species born in darkness, evolved in darkness, perfectly adapted to extracting all the information they need from non-visual sources. A deep-sea fish does not yearn for light, does not feel the absence of color or brightness, because its nervous system is organized around the senses it possesses, around the inputs that actually exist in its environment, and those inputs create a complete perceptual world, a rich sensory landscape where objects have chemical signatures and pressure profiles and electrical fields, where the concept of seeing in the visual sense simply does not apply, does not exist as a possibility or a goal, exists only in environments where light provides information, where evolution discovered that detecting photons offered advantages worth the considerable cost of building and maintaining eyes, of devoting significant neural processing capacity to interpreting visual input, of organizing behavior around what can be seen rather than what can be smelled or felt or sensed through electrical fields. The deep ocean thus contains organisms that are utterly complete in themselves, perfectly matched to their environment, lacking nothing that their environment could provide, requiring nothing that their environment withholds, existing in a state of equilibrium between organism and habitat that represents the endpoint of millions of years of evolutionary refinement, of natural selection testing variants and keeping those that work best in darkness, in cold, in pressure, in scarcity, until what remains are species so precisely adapted that they seem to have been designed for this specific place, this specific set of conditions, this realm of permanent night, where light is not missed because it was never part of the contract, never part of the terms under which life here operates. never part of what defines success or failure in the slow, patient business of surviving in darkness that is absolute but not, to those who live within it, absolute in any negative sense, simply present, simply the medium, simply the way things are and have always been. The organisms that inhabit the bathypelagic zone are not refugees from brighter waters, not species that wandered into darkness by accident and found themselves trapped, unable to return, but rather lineages that evolved here, that originated in these depths or colonized them so long ago that any memory of surface conditions has been erased from their genetic heritage, that have spent millions of years being shaped by selection pressures unique to this environment, refined by the patient work of evolution, testing variations and keeping what succeeds, discarding what fails, until the result is a suite of adaptations so specific, so finely tuned to life in permanent darkness, that these organisms could no more survive in bright surface waters than surface organisms could survive here, transported to depth without preparation, without the gradual process of adaptation that occurs across generations rather than within individual lifetimes. A deep-sea fish brought suddenly to the surface would experience problems not because the light is too bright, though that might disorient it, but because the pressure change would be catastrophic, would cause dissolved gases in its tissues to come out of solution, forming bubbles that damage cells and block circulation. The same decompression sickness that human divers experience if they ascend too rapidly from depth. And beyond that, the warmer temperature would accelerate its metabolism beyond what its body can sustain, would demand energy expenditure that its slow, economical physiology cannot provide, would essentially force it to operate at a pace that feels, to an organism adapted to cold and stillness, like running at full speed continuously, exhausting resources faster than they can be replenished, burning through energy reserves that are meant to last weeks or months, not hours. These organisms are born in darkness, develop in darkness, live their entire existence in darkness, and at no point in their life cycle do they encounter or expect or require light. Reproduction occurs in darkness. Eggs are laid and fertilized in darkness. Larvae develop and grow in darkness. Juveniles hunt and feed and mature in darkness. Adults eventually spawn and die in darkness, and the cycle continues, generation after generation, without ever intersecting with the bright surface world, without ever needing to, because everything necessary for life, food, mates, habitat, the basic requirements of metabolism and growth and reproduction, exists here, is available here, can be obtained here through strategies that do not involve vision, that do not assume brightness, that work perfectly well in conditions that surface organisms would find utterly inhospitable. The deep ocean is not a marginal environment for these species, not a harsh frontier where life barely clings on, but rather their native habitat, the place where they are most comfortable, most capable, most successful, where their adaptations provide advantages rather than merely compensating for difficulties, where the cold slows their metabolism in ways that reduce energy needs, where the darkness protects them from visual predators that dominate shallower waters, where the pressure creates stability, creates a physical environment that changes so slowly that organisms can specialize without risk, that their specializations will become obsolete, will stop matching the conditions they evolved to exploit. The concept of missing something requires comparison, requires knowing that an alternative exists, that other organisms in other places experience different conditions and have access to different resources, and it is unclear whether deep-sea organisms possess any such awareness, any sense that their lives are in any way incomplete, that they lack capabilities or experiences that would improve their existence, that they are adapted to scarcity rather than abundance, to darkness rather than light, because from their perspective, if we can use that word for organisms with nervous systems far simpler than ours, with no capacity for self-reflection or abstract thought, the conditions at depth are simply the conditions, our reality, are the parameters within which life operates and has always operated, and success means not transcending those parameters, but working within them, finding the strategies that extract maximum benefit from what is available, that convert the sparse resources of the deep ocean into growth and reproduction and the continuation of genetic lineages that extend back through geological time, that connect modern species to ancestors that first colonized these depths hundreds of millions of years ago, before humans existed, before mammals existed, before many of the surface lineages we think of as ancient had even appeared, back when the ocean's basic structure, its layering, its pressure gradients, its darkness below certain depths, was already established, was already creating the conditions that would select for the adaptations we see today in creatures that seem alien, seem impossible, seem like they should not work, but do work, do thrive, do represent successful solutions to the problem of living in permanent night. There is something quietly profound about organisms that never see, that possess no visual system capable of forming images, yet navigate their environment with precision, locate prey with efficiency, find mates with reliability, all without the sense that humans rely on more than any other, that we assume to be fundamental, essential, the primary way of knowing the world. These deep-sea species remind us that vision is not universal, is not the only way or even necessarily the best way to gather information about surroundings, that it is simply one solution among many that evolution has discovered, one that works well in certain environments, bright, clear, where light is abundant but becomes less useful, eventually useless, eventually costly without benefit, in environments where light does not penetrate, where other senses provide better information, where the metabolic expense of maintaining eyes and the neural machinery to process visual input could be better spent on enhancing chemoreceptors or electroreceptors, or the lateral line system, on developing longer, more sensitive barbells, or more efficient digestive systems, or slower metabolisms that allow survival on minimal food input, all of which contribute more to fitness in darkness than eyes ever could. The diversity of life in the bathypelagic zone, the hundreds of species of fish, the multitude of invertebrates, the microorganisms that process organic matter and recycle nutrients, exists entirely outside human awareness, unfolds in conditions we cannot experience without technology, follows patterns we can observe but perhaps never fully understand because our own sensory systems, our own embodied experience, is so different, is so bound to light and surface conditions, to atmospheric pressure and moderate temperatures, that even when we descend in submersibles, even when we illuminate small patches of the deep ocean with powerful lights and cameras, we are imposing our perceptual framework on an environment that does not operate according to that framework, that is organized around different principles, different sensory modalities, different strategies for dealing with fundamental biological challenges, like finding food and avoiding predation, and reproducing successfully enough to maintain populations across generations that accumulate slowly, that might require decades to reach maturity, to grow large enough to spawn, to produce offspring that will themselves require decades to mature, creating cycles of reproduction that operate on timescales utterly different from those we observe in surface waters, where generations turn over rapidly, where species can adapt quickly to changing conditions because each year brings new cohorts, new genetic variants tested against current selection pressures. But in the deep ocean, change happens slowly. Populations respond to selection gradually, and the species we observe today are, in some sense, living fossils, are forms that have persisted largely unchanged for millions of years because the environment they inhabit has persisted largely unchanged, has offered no reason for major innovations, no pressure for rapid evolution, only the steady, patient refinement of adaptations that already work, that have always worked, that will continue working as long as the ocean maintains its depth, its darkness, its cold, its pressure, its fundamental character as a realm where light does not reach and time flows differently. Humans evolved under skies that cycled between light and dark, under a sun that rose and set with reliable rhythm for millions of years. And this exposure to alternating conditions shaped not just our visual systems, not just our circadian clocks, but something deeper, something that persists even now in bodies that spend most of their time indoors, that experience artificial light at all hours, that have access to illumination whenever desired through switches and screens and devices that eliminate darkness from daily experience if we choose, if we decide that night is inconvenient, that sleep can be deferred, that the ancient pattern of rest during darkness and activity during light can be overridden by will or necessity or the demands of modern life. Yet the biology remains, the deep structures persist, the cellular machinery that expects darkness continues to operate according to instructions written into our genes across evolutionary timescales, far longer than the few thousand years of human civilization, far longer than the century or so since electric lighting became commonplace, far longer than any cultural practice or technological innovation that might convince us we have transcended our evolutionary heritage, that we are no longer bound by the rhythms that organized life for our ancestors, who had no choice but to rest when night fell, who experienced darkness not as something optional, not as something that could be banished with the flip of a switch, but as an unavoidable feature of existence, as predictable as sunrise, as necessary as breath. The circadian system that governs our sleep-wake cycles, that regulates hormone release and body temperature and cognitive performance across the 24-hour day, depends on darkness, not just the absence of activity, not just the cessation of stimulation, but actual darkness, the reduction of light below certain thresholds that signal to the suprachiasmatic nucleus that night has arrived, that it is time to initiate the cascade of changes that prepare the body for sleep, that trigger the release of melatonin from the pineal gland, that begin the process of slowing metabolism, lowering core temperature, shifting neural activity toward patterns that support rest and restoration, rather than alertness and engagement with the external world. This system evolved because darkness, for organisms living on land under a stable star, occurs predictably, provides reliable information about time of day, about when conditions favor rest over activity, and throughout our evolutionary history, throughout the millions of years that our primate ancestors spent in forests and savannas, darkness meant safety, meant the opportunity to stop scanning for threats, to stop foraging, to stop the constant vigilance that daylight demanded, because darkness reduced visibility for predators as much as for prey, created a kind of truce where the risks of movement outweighed the benefits, where the smart strategy was to find shelter and wait for dawn, to accept that half of each day would be spent in a state of reduced consciousness, of vulnerability, but also of necessary recovery, of giving the body time to repair tissues, to consolidate memories, to process the experiences of waking hours and integrate them into the neural structures that support learning, that allow experience to become knowledge, that transform today's challenges into tomorrow's competencies. Modern humans, particularly those in industrialized societies, in cities where artificial light has made night nearly as bright as day, where screens emit blue wavelengths that mimic sunlight and confuse the circadian system, where sleep is often treated as optional or expendable, as something to be minimized in favor of productivity or entertainment, or the endless scroll of information that demands attention at all hours. These humans are conducting an experiment, testing whether the body can adapt to conditions it never encountered during its evolutionary development, whether the need for darkness is fundamental or merely habitual, whether we can eliminate night from our experience without consequences, without paying prices that accumulate slowly, that manifest as disrupted sleep patterns, as metabolic disorders, as increased risk of depression and anxiety, and the various ailments that correlate with chronic sleep deprivation, with circadian misalignment, with living according to schedules that ignore the ancient rhythms that our cells still follow, still expect, still require, despite our best efforts to convince ourselves otherwise. The research is clear, has been clear for decades. Darkness matters, not as a cultural preference or a psychological comfort, but as a biological necessity, as a signal that the body uses to coordinate thousands of processes, to synchronize the activity of organs and tissues and cells across different time zones within the organism, to maintain the temporal organization that allows complex multicellular life to function efficiently, to allocate resources appropriately between growth and repair, between activity and rest, between engaging with the environment and maintaining internal systems that require sustained attention but cannot receive it while the organism is simultaneously processing external stimuli, navigating space, solving problems, interacting with other individuals. The deep ocean's permanent darkness offers a kind of thought experiment about what happens when light is not just reduced or avoided, but genuinely absent, when organisms evolve in conditions where the daily cycle of light and dark simply does not exist, where darkness is not a temporary state to be endured or hidden in, but the permanent baseline condition. And what we find is that life adapts, thrives even, develops entirely different strategies for organizing time and activity, for coordinating behavior and physiology, for dealing with the fundamental challenges of existence without reference to the sun's position, without the cues that surface organisms use to structure their days. There is no evidence that deep-sea organisms suffer from their lack of light, no indication that they are impaired or disadvantaged by living in permanent night. They are simply different, have taken a different evolutionary path, have discovered alternative solutions to problems that surface organisms solve with circadian rhythms and light-dependent behaviors. And in doing so, they demonstrate that darkness is not inherently negative, is not deprivation, is not absence in the sense of lacking something essential, but is rather a state, a condition, a set of parameters within which life can exist and flourish if it evolves the appropriate adaptations, if it learns to work with darkness rather than fighting against it, if it accepts night as a resource rather than an obstacle. Perhaps this is what humans have forgotten, or what we are in the process of forgetting, that darkness is not the enemy of life but its partner, that the cycle of light and dark creates opportunities that constant light cannot provide, that night offers something day cannot, that rest requires not just cessation of activity but actual darkness, actual reduction of sensory input, actual permission to stop monitoring the environment and turn attention inward to the maintenance and repair work that keeps complex organisms functional, that allows tomorrow to arrive with resources restored, with capacity renewed, with the possibility of engagement and alertness, and the cognitive clarity that comes only after adequate sleep in proper darkness, after honoring the biological truth that we are diurnal creatures, designed by evolution to be active in light and rest in dark, and that attempting to override this design comes with costs. Darkness in the human experience has become associated with danger, with uncertainty, with the unknown and the threatening, and this association is not entirely unfounded. Our ancestors did face real risks in the night, did encounter predators whose vision worked better than theirs in low light, did navigate environments where visibility mattered for safety, for avoiding falls or injuries or becoming lost. But somewhere in the translation from evolutionary necessity to modern anxiety, darkness itself became the problem, rather than what darkness might conceal. And we have responded by eliminating it wherever possible, by flooding our homes and streets and cities with light, by creating environments where night exists only as a technical designation on the clock, where the sky might be dark but the ground level remains illuminated, remains visible, remains under the same visual surveillance that daylight provides, as if the solution to night's dangers is to eliminate night entirely, to refuse its presence, to insist on perpetual day through artificial means that our ancestors could never have imagined. That would have seemed like magic or miracle. The ability to command light whenever desired, to banish darkness with simple gestures, with switches and buttons and the electrical infrastructure that makes constant illumination not just possible, but cheap, convenient, expected as a basic feature of civilized life. But darkness, the real biological darkness that the human body expects, that the circadian system requires to function properly, is not dangerous. It is sanctuary, is the condition under which rest becomes possible, under which the brain can shift from the alert, externally focused state that daylight demands into the internally focused state that sleep requires, that allows consciousness to dissolve into the fragmented, non-linear experience of dreaming. that permits the deep, slow-wave sleep, during which growth hormone is released, during which immune function is enhanced, during which the cellular repair work that cannot happen during waking hours proceeds without interruption, without the competing demands of sensory processing and motor control and the constant evaluation of threats and opportunities that characterizes conscious awareness. Sleep is not merely rest, not merely the absence of activity, but an active state with specific functions, specific processes that occur only when consciousness recedes, only when the brain is released from its duties of maintaining awareness and can turn its considerable metabolic resources toward maintenance, toward consolidation, toward the synaptic pruning and memory integration and emotional processing that transform experience into learning, that allow yesterday's confusion to become today's clarity, that perform the essential alchemy of converting lived time into neural structure, into the patterns of connectivity that constitute knowledge, skill, personality, the accumulated residue of all the days we have survived and all the choices we have made. The deep ocean's darkness is permanent, absolute, a condition that never changes regardless of what happens at the surface, and organisms there have adapted by eliminating sleep entirely in some cases, by finding other ways to rest and restore that do not depend on circadian rhythms, that do not assume a cycle of activity and quiescence linked to external light levels. But humans cannot do this, are bound to our evolutionary history as diurnal creatures who spent millions of years under skies that brightened and darkened with reliable regularity, who developed sleep as a response to night's predictable arrival, as a way to make productive use of hours when vision-dependent activities became difficult or dangerous, and we cannot simply decide to abandon this adaptation, cannot will ourselves into constant alertness, cannot override the biological imperative for rest that manifests after approximately 16 hours of waking, that builds pressure for sleep through the accumulation of adenosine in the brain, through the depletion of glucose and the accumulation of metabolic waste products that slow neural processing, that make continued consciousness feel increasingly difficult, increasingly costly, until finally the body insists, demands rest, forces sleep even when circumstances suggest it would be better to remain awake, to stay vigilant, to keep processing the environment for threats or opportunities. Darkness facilitates this transition, removes the light that signals stay alert, that tells the suprachiasmatic nucleus that daytime continues, that it is not yet time to release melatonin, not yet time to lower body temperature, not yet time to shift into the cascade of changes that constitute falling asleep, and without darkness, with bright light exposure continuing into evening hours, with screens emitting blue wavelengths that the circadian system interprets as sunlight, with bedrooms that never achieve true darkness because of streetlights or electronics, or the ambient glow of cities that never sleep. The transition becomes harder, requires more effort, takes longer, feels less natural, less like surrendering to an inevitable process, and more like forcing something that should be automatic, that should happen without conscious intervention, that happened easily for our ancestors who had no choice but to accept darkness when it arrived, who could not banish it or postpone it, or pretend it did not exist, who simply lived with night as part of the pattern, as half of existence, as necessary as day, and perhaps in its own way, more important because night offered what day could not: restoration, recovery, the chance to stop performing, stop monitoring, stop maintaining the exhausting vigilance that social life demands, that consciousness demands, that being awake in a world full of other beings and competing interests and constant change demands from creatures whose survival has always depended on paying attention, on noticing, on responding appropriately to what happens around them. The permission to stop, to close eyes, to let awareness dissolve into sleep's fragmented landscapes. This is what darkness provides, what it has always provided, what it still provides when we allow it to exist, when we create spaces that honor darkness rather than fighting it, that recognize night as a necessary partner today rather than as a problem to be solved through artificial illumination, through the insistence that human activity need not accommodate the planet's rotation, need not pause for night, can continue around the clock in shifts and schedules that ignore biological rhythms in favor of economic productivity or personal preference, or the belief that sleep is somehow optional, somehow negotiable, somehow less important than the countless activities and entertainments and obligations that claim our waking hours and extend them beyond what evolution prepared us for, beyond what our bodies can sustain without cost. The research documenting these costs is overwhelming, spanning decades, confirming what should be obvious, that humans need darkness, need night, need the full cycle of light and dark to function optimally, to maintain health, to preserve the cognitive and emotional and physical capacities that make life not just survivable, but worth living, that allow us to engage with the world from a foundation of rest rather than exhaustion, of restoration rather than depletion, of systems that have been given time to repair rather than systems pushed continuously toward failure. Perhaps the deep ocean's lesson, then, is not about adapting to permanent darkness, but about respecting the darkness we have, about recognizing that night's absence is not liberation but loss, that in eliminating darkness, we have eliminated something essential, have disrupted rhythms that organize not just sleep, but countless other processes, have created an environment our bodies do not recognize, cannot fully adapt to, can only endure with varying degrees of success while accumulating the subtle damages that manifest as poor sleep, as metabolic dysfunction, as the feeling that rest never quite restores, that waking brings fatigue rather than energy, that something fundamental is missing from life, even when we cannot name exactly what it is, cannot point to the specific absence except to say that we are tired, always tired, in a way that sleep seems unable to fix, because the sleep itself is compromised, is incomplete, is happening in conditions that do not support the deep restoration that darkness, real darkness, evolutionary darkness, makes possible. Darkness is not merely the absence of light, but the presence of something else. Something that cannot exist when brightness dominates, when the visual sense remains active and demanding, when the world insists on being seen rather than felt or imagined, or simply allowed to exist without constant observation, without the cataloguing and evaluating that vision encourages, that makes everything into objects to be identified, distances to be judged, colors to be named, patterns to be recognized. In darkness, the other senses emerge, become primary, and with them comes a different relationship to space and time, to the environment and to one's own body, because without vision to anchor perception to external objects, to create the illusion of separation between self and surroundings, awareness becomes more internal, more proprioceptive, more attuned to breathing and heartbeat and the subtle sensations that consciousness usually ignores in favor of visual information, in favor of the bright, detailed, endlessly complex world that eyes present, that demands interpretation, that keeps the mind engaged in processing, in thinking about what is seen, rather than simply experiencing what is felt. Children often fear darkness, and this fear is understandable, is perhaps even adaptive in environments where night brought genuine dangers, where the inability to see meant vulnerability, meant that threats could approach undetected. But somewhere in development, most people learn that darkness itself is safe, that it poses no threat, that what they feared was not darkness, but what darkness might hide. And once that distinction becomes clear, once darkness is understood as neutral, as simply a condition rather than a danger, it can transform from something to be avoided into something valuable, into a kind of sanctuary that offers respite from the constant stimulation of modern life, from the visual noise that fills waking hours, from the screens and lights and colors and movements that compete for attention every moment, that make consciousness feel like managing an overwhelming stream of input rather than like existing peacefully in a world that does not require constant monitoring, constant evaluation, constant response. The deep ocean's organisms do not have this transition to make, do not need to overcome fear or learn to value darkness, because they have never known anything else, have never experienced the alternative, have evolved in conditions where darkness is simply the baseline, the medium, the context within which everything else occurs. And perhaps there is something we can learn from this, from the fact that life not only survives in permanent darkness, but thrives, develops complexity, establishes Ecosystems and relationships and patterns of behavior that work perfectly well without any reference to light, without any assumption that vision is necessary or even useful. These organisms are not struggling in darkness, are not making do with less, are not compromised or limited by the absence of light. They are complete, are fully functional, are as successful in their lightless realm as any surface organism in the bright waters above. And this completeness, this wholeness in darkness, suggests that darkness is not inherently hostile to life, is not an obstacle that must be overcome, but rather a condition that can be inhabited, that can become home, that can support not just survival but flourishing if the appropriate adaptations are in place, if the organism or the species or the individual learns to work with darkness rather than against it. For humans, darkness offers what constant light cannot: the opportunity to stop processing visual information, to rest the neural pathways that interpret sight, to allow consciousness to soften and drift toward sleep without the constant pullback toward alertness that bright light creates, that tells the brain there is still more to see, still more to attend to, still reasons to remain vigilant rather than surrendering to rest. In darkness, the world recedes, becomes less demanding, asks less of us, permits the transition from doing to being, from engaging to resting, from the active management of attention that waking life requires to the passive acceptance of whatever arises in the uncontrolled theatre of dreams, where logic dissolves and time becomes non-linear and the rules that govern waking consciousness no longer apply, where the mind can process experience in ways that rational thought cannot, can make connections and associations that would be dismissed as nonsensical in daylight, but which contain their own kind of sense, their own logic that operates below the level of language, that works with images and emotions and the deep patterns that structure personality and memory and the ways we understand ourselves and our relationships to others and to the world. Darkness, then, is not deprivation, but permission. Permission to stop, to rest, to let go of control, to allow processes to unfold that cannot occur under conscious direction, that require the dissolution of the waking self, the temporary surrender of agency and awareness that sleep represents, that feels like disappearance, like a small death each night, like a dissolution that the waking mind resists even as the body demands it, even as exhaustion builds and makes continued consciousness increasingly difficult, increasingly painful, until finally resistance collapses and sleep arrives not as choice, but as inevitability, as the body's insistence that rest cannot be deferred indefinitely, that the maintenance work of sleep must happen regardless of what consciousness prefers, regardless of what tasks remain undone, what worries persist, what stimulation might still be available through screens and lights, and the endless stream of content that modern life provides to fill every moment, to ensure that boredom and stillness and quiet and darkness never need to be experienced if we choose to avoid them. If we decide that engagement is always preferable to rest, that activity is always superior to stillness, that the waking world contains everything worth having, and darkness offers nothing but absence, but emptiness, but the void that must be filled or fled or simply endured until morning returns and the cycle can begin again. But the deep ocean suggests otherwise, demonstrates that darkness can be inhabited, that permanent night does not mean permanent void, that absence of light does not equal absence of life or complexity or beauty or value, that darkness is a state, a condition, a place where different rules apply and different strategies succeed, where organisms have found ways to live that do not depend on the assumptions that surface life makes, that do not require vision or circadian rhythms or any of the adaptations that seem essential in bright environments but become optional, become negotiable, become expendable when darkness is absolute and permanent and reliable, when it can be trusted never to change, never to suddenly give way to light that would expose whatever strategies darkness permits, whatever behaviors work only when visibility is eliminated, when the world cannot be seen, but only sensed through other means, through touch and chemistry, and pressure and electrical fields, through Information channels that light-adapted organisms rarely develop to their full potential because vision works so well, provides such rich information that investing in alternative senses seems unnecessary, seems like wasted effort when eyes can simply look and see and know instantly what surrounds them, what threatens, what offers opportunity. In giving up constant light, in accepting darkness as a necessary part of each day's cycle, humans would not be sacrificing something valuable, but reclaiming something lost, something that our ancestors knew without thinking, without needing to be told, because their lives moved with the sun, ended with the night, resumed with the dawn, and the cycle felt natural, felt right, felt like the way things should be, rather than like a constraint to be overcome, a limitation to be escaped through. Technology, through the insistence that human life need not accommodate natural rhythms, can operate on schedules determined by convenience or productivity or preference, rather than by biology, by the deep structures that evolution built into our cells and our brains and our hormonal systems, structures that still expect darkness, still require it, still function best when the full cycle is honored rather than truncated, rather than compressed into whatever minimum can be managed without. Immediate collapse, without acute failure, though chronic degradation accumulates silently, manifests gradually, creates conditions that feel normal because everyone experiences them, because constant partial exhaustion has become so common that we mistake it for the baseline human state, rather than recognizing it as the consequence of living out of phase with our own biology, of treating darkness as optional when it is, for creatures like us, as necessary as food, or water, or air. Below 4,000 meters lies the abyssopelagic zone, the abyss, a word that carries connotations of bottomless depth, of falling forever, of voids that have no end, but which in reality describes the vast plains of the ocean floor, the relatively flat expanses of sediment that cover most of the deep ocean basin, that extend for thousands of kilometers between the continental margins and the mid-ocean ridges, that represent the majority of Earth's seafloor by area, though humans have mapped. These regions, less thoroughly than the surface of the Moon or Mars, have sent fewer expeditions to explore them than to visit the International Space Station, because the abyss is not easily reached, not casually visited, requires technology and planning and resources that few institutions possess, that few missions justify, because what lies down there, the darkness and cold and pressure and the slow, patient life that has adapted to these conditions, does not promise immediate returns, does not offer resources we know how to extract, does not present mysteries whose solutions would transform technology or medicine or our understanding of life's possibilities, or at least does not present such mysteries obviously, does not advertise them in ways that secure funding or capture public imagination the way space exploration does, the way the search for extraterrestrial life does, even though the deep ocean may be, in its own way, as alien as any world orbiting distant stars, as fundamentally different from surface conditions as Mars or Europa, as capable of surprising us with adaptations and ecosystems and biological strategies that challenge assumptions about what life requires, what conditions are tolerable, what environments can support not just survival but complexity, diversity, the intricate webs of interaction that characterize mature ecosystems. And then, deeper still, past the abyssal plains, where the seafloor descends into trenches, the Hadal zone, named for Hades, the Greek underworld, the realm of the dead, though nothing about these trenches suggests death, suggests ending, suggests absence of life. Only depth that continues past where we expected the bottom to be, past the 4,000 or 5,000 meters that characterizes most ocean floor, down to 6,000, 7,000, 8,000 meters, descending into cracks in the Earth's crust, where one tectonic plate slides beneath another, where the planet's geology creates depressions so deep that Mount Everest, if placed in the Mariana Trench, would be covered by more than 2 kilometers of water, would disappear entirely beneath the surface, would become just another feature of the seafloor, invisible from above, known only to instruments that can measure depth with precision. that can map the contours of these abyssal canyons that represent the deepest accessible places on Earth, the farthest points from the surface without actually leaving the planet, without drilling through kilometers of rock to reach the mantle below. At 11 kilometers depth, at the bottom of Challenger Deep, the pressure exceeds 1,000 atmospheres, means that every square centimeter experiences more than 1 metric ton of force, a compression so extreme it seems incompatible with life, seems like it should sterilize the environment, should make biological processes impossible because the molecular machinery of cells requires certain spatial arrangements, certain distances between atoms and proteins and membranes that such pressure would distort beyond function, beyond repair, beyond the tolerance limits that terrestrial life operates within. Yet life exists even here, even at the bottom of the deepest trench, even under conditions that seem to exceed what organic chemistry should allow, because amphipods have been found at these depths, small crustaceans that thrive under pressure that would instantly kill surface organisms, that have adapted their cellular structures, their proteins, their membranes to remain flexible and functional when compressed to densities that approach the limits of what water itself can withstand before its properties change, before hydrogen bonds reorganize into exotic ice formations that exist only in laboratory conditions or in the cores of frozen moons orbiting gas giants in the outer solar system. These creatures are not barely surviving, not clinging to existence at the edge of possibility, but are abundant, are active, are feeding and reproducing and going about the business of life in an environment that represents the extreme edge of Earth's biosphere, the deepest inhabited zone, the place where the requirements of life meet the constraints of physics and somehow find accommodation, somehow negotiate terms that allow metabolism to continue, growth to occur, populations to persist. Across generations that have inhabited these depths for millions of years, that evolved here or migrated here from shallower waters and adapted, that discovered through natural selection's patient testing that life at extreme pressure is possible if you build your cells correctly, if you use the right proteins, if you accept pressure as simply another parameter, another condition to be met through appropriate design, rather than resisted or avoided or feared. The Hadal zone is the ocean's final depth, the last layer before the seafloor itself, before solid earth replaces liquid water, before geology becomes the primary subject rather than oceanography. And at these depths, the darkness that began at a few hundred meters below the surface reaches its fullest expression, its most complete manifestation, because here there is no light, has never been light, will never be light, unless humans bring it, unless research vessels descend with powerful lamps that reveal the sediment and the organisms and the manganese nodules that litter the seafloor like stones in a field, like artifacts of slow geological processes that precipitate minerals from seawater across millions of years, building spherical accumulations that rest on the bottom, waiting to be discovered, waiting to be studied, waiting to be understood as part of the planet's mineral cycles, part of the way Earth processes dissolved elements and concentrates them into forms that might eventually become accessible to organisms or to humans who develop the technology to harvest them, to extract them, to bring them back to the surface where pressure and temperature are moderate, where resources can be processed using methods developed for terrestrial mining, for land-based industry that assumes atmosphere and reasonable temperatures and the ability to work in light, to see what you're doing, to organize activity around visual information that the deep ocean simply does not provide, cannot provide, will never provide, no matter how much we might wish it otherwise, no matter how useful it would be to have illumination that doesn't require bringing your own lights, that doesn't depend on artificial sources that consume power and have limited duration, and must eventually be brought back to the surface to be recharged, to be maintained, to be prepared for the next descent into darkness that is absolute, permanent, patient, that has existed since the ocean formed and will exist until the ocean evaporates or freezes or undergoes some transformation so complete that its current structure no longer applies, no longer describes the reality of water on Earth. The ocean floor in the trenches is not flat, but varied, contains features and formations, hills and valleys on smaller scales, evidence of currents that flow even at these depths, evidence of sediment transport and deposition, of geological processes that continue regardless of pressure, regardless of darkness, regardless of the fact that no human witnessed them until the last few decades, until technology made deep-sea exploration possible. Perhaps what the ocean teaches, in its slow descent from light to dark, from the trembling surface to the depths where pressure becomes absolute and darkness becomes permanent, is not a lesson about adaptation or survival or the remarkable capabilities of life in extreme environments, but something quieter, something that has less to do with biology and more to do with acceptance, with the recognition that most of the world exists beyond our direct experience, beyond the range of our senses, beyond the illuminated zones where we feel comfortable, where we understand the rules, where visibility creates the illusion that we can know what surrounds us, that we can catalogue and measure and eventually comprehend the systems we inhabit, the planet we live on, the ocean that covers most of its surface and extends downward through kilometers of water that have never been fully explored, never been completely mapped, never been witnessed in their entirety by any human eye or instrument or consciousness. The darkness that begins a few hundred meters below the surface and continues to the deepest trenches is not waiting to be eliminated, not asking to be illuminated, not presenting itself as a problem that requires our solution or our attention, but simply existing, simply being what it has always been, the normal state of most ocean water, the condition under which most marine life evolved, the medium that supported complexity and diversity, and the patient work of natural selection for hundreds of millions of years before humans existed, before we developed the capacity to wonder about what lies beneath the waves, to build vessels that could descend into that darkness and return with information, with images, with specimens that prove life continues where we assumed it could not, where conditions seemed too extreme, too hostile, too far removed from the bright surface world we know. The night air over open water still moves. With that same faint coldness it carried at the beginning, still suggests depths that have never known warmth, temperatures that remain constant regardless of season or latitude or the sun's position overhead. And if you find yourself here again, at this hour, having followed the gradual disappearance of light from surface to sea floor, from bright afternoon to twilight to midnight, to the absolute darkness of the abyss, perhaps you carry now not answers, but a different kind of understanding, one that does not require explanations or conclusions or the satisfaction of having solved the mystery, having penetrated the unknown and made it known, but instead accepts that some things, most things if we are honest, exist beyond our full comprehension, beyond our ability to experience directly, beyond the reach of the senses and technologies that extend them, and that this inaccessibility does not diminish their reality, does not make them less important or less worthy of consideration, only reminds us that the world is larger than our perception of it, that consciousness occupies a small space within a much vaster existence, that most of what happens without witness, without record, without any awareness turning toward it and making it known, making it part of the shared story we tell about Earth and its inhabitants and the processes that have been unfolding since long before we arrived and will continue long after we are gone. Darkness, whether in the ocean depths or in the night that arrives each evening, whether in the permanent midnight of the Bath hypelagic zone, or in the temporary darkness that humans need for sleep, for rest, for the restoration that makes tomorrow possible. This darkness is not absence, but presence, not void, but substance, not problem, but solution. To problems we have perhaps forgotten how to recognize, having spent so much time trying to eliminate night, trying to extend day indefinitely, trying to make everything visible, everything accessible, everything subject to the same scrutiny and measurement and control that we apply to the bright zones where we feel competent, where our adaptations serve us well, where the world makes sense according to the assumptions we carry from our evolutionary history as diurnal primates who learn to navigate by sight, who built civilizations around the solar cycle, who never imagined they would need to justify darkness, to defend night's value, to argue for the preservation of conditions that were, until very recently in historical terms, simply unavoidable, simply part of what it meant to be alive on a rotating planet orbiting a star. The ocean continues its work, regardless of whether we understand it, regardless of whether we explore it or leave it alone, regardless of whether we learn its secrets or allow them to remain hidden in depths we cannot easily reach, in darkness that persists because light cannot penetrate so far, cannot carry energy through so much water, cannot maintain its coherence across the distances that separate surface from sea floor in the deep basins where most of the ocean's volume resides, where most of its organisms live, where most of its processes occur in silence and stillness, and the patient accumulation of time that requires no audience, no observer, no consciousness turning toward it and asking what it means, why it matters, what we should think about its existence. If this journey brought you a sense of calm, you can subscribe to Quiet Science and continue exploring these silent depths with us.